Good afternoon, everyone. We're just going to let Zoom do its thing and let everybody trickle in who's signed into the webinar. So just give us 1 or 2 minutes and then we'll get started and kick things over to Suzanne for the webinar. Okay, well, in the interest of time, we'll get things started. I know there's a few more people just coming on, but once I finish my introductory remarks, everybody should be in here. Just want to say good afternoon, everyone. We really do appreciate you joining us for today's webinar, sponsored by Mitsubishi Electric Heating and Cooling. We have a very interesting topic here today that I think we're looking forward to digging into some more. As we all know and as we've all heard about, Canada's built environment is being increasingly targeted for its ability to lower greenhouse gas emissions and increase energy efficiency. And one of the ways this is being done is through electrification. Many developers, many commercial developers and owners are looking at how they can reduce their operating costs and ultimately lower emissions at the same time. So we know this is a very important topic for the country. We know it's a very important topic for the economy, and we know it's a very important topic for the mechanical contracting sector. So with that being said, we're very pleased to have with us Susan Wiltshire, who's been active in the renewable energy industry for the past 20 years. Suzanne's going to talk a little bit more today about building electrification, as well as the role the mechanical contracting sector is going to play to get to destination net zero. So with that being said, Suzanne, the floor is yours.
Thanks very much. Nice to meet everybody, and thank you for spending some time with me today. First of all, just to give you a hint of where I'm coming from, I deal with developers, large scale, mostly commercial developers. And I get their perspective all day long and try to work with them. I've been working with many of these developers for 5 and 10 years. Individual projects easily span 3 to 5 years. It's the mechanical contracting piece that comes in at the end. And it's critical. We can work all the time we want, all the years we want to develop something. But if the mechanical contractors aren't there for us when we need them, it's a real problem. So I really appreciate you joining me today. I really think this is an important conversation. So as we talked about, there has been a very rapid and dramatic transition to electrification. It's been coming for a long time, but it's here and it's arrived with a big bang, spurred on by many factors, including the economy, COVID, everything stalled, we couldn't build. Now there seems to be a lack of building compared to what is required by the population increase. So lots of dynamics at play here, but they've all seemed to arrived at one place at one time, and that is electrification of buildings. So in Canada, we start with, our mandates, and it's the government that sets that. The federal government has been leading this charge, for many years, but since 2015 specifically, they've targeted many avenues, if you will, that all lead into this electrification and clean electric society, including renewables and all of that. But right here, the buildings, are a big thing. And we all know that they are predominantly fossil fueled. So electric heat pumps is the target. This is what's been decided. It's been tested, tried. We've worked with so many different angles to be able to find out what is the best solution. And electric heat pumps seem to be what has fallen out, what most are agreeing is where we need to go. We need labor. We need, as I said, contractors to be able to install these. And this is going to have to increase hugely. We do not have the resources currently to accomplish the growth, let alone the transition that we need to make. And so it's urgent. And we're seeing it every day in heat domes, droughts, the wildfires this summer, sometimes the crazy flooding, and sometimes all of it, one right after the other in rapid succession. So Canada is not missing out on these events. They're occurring here right at home. So the contractors are very key. I've mentioned that. And this is something I want to target on today and see if I can show you some ways that you can participate. And I know you are already, but it needs more. We need more people engaged. We need more contractors training. And it's going to impact how you do your business. So there are some new demands on the industry. So certainly electricians, if you're going to electrify things, you need electricians, no question about it. But they also have to integrate with the mechanical side of things. Certified heat pump installers is just, and that includes refrigerant licenses, not just mechanical tin and fixtures and ducting. It requires refrigeration and refrigeration licensing. And right now it's still fragmented. We still have individual refrigerant companies who subcontract with other mechanical companies. We need that integrated, and we need that high level of skill and professionalism in each of our mechanical companies. So the new trends that are driving this, we've all certainly heard about carbon reduction. I don't know how many of you have bought an EV yet, but it's certainly on my list as my car ages. In projects, energy modeling is now mandatory. This is something new in the last 10 years, but it's become increasingly essential. Any developer who wants to build a building these days is absolutely required to do energy modeling, and fairly early in the process, because they can't get permits. They can't submit their applications unless they meet certain energy criteria. And there's various criteria. Some of it is energy intensity, some of it is carbon reduction. So they do have to do a considerable amount of analysis, and there are dedicated energy modeling firms that they will often engage before they even necessarily get involved with their mechanical engineers. So again, the integration, the understanding between the disciplines of how we build these buildings is absolutely essential. There's a lot more, as bottom of the screen, monitoring, testing, verification. This is all essential. It has to be proven. You have to know what you're doing, and it has to be documented properly and properly put forth. So it's just a mandatory energy efficiency targets that have to be met before a developer can even get off the planning. So how can mechanical contractors get involved in all of this? It is change. It's massive change. And some people who have been in the industry for many, many years, it does often require new training, new learning, new understanding, but it's more than just learning how do you install this piece of equipment as opposed to that piece of equipment. That part's easy. You could be trained on that. But a lot of it is an attitude. A lot of it is an understanding that this is not only good for the environment, it's good for the people living in each house, each housing unit that we build. It's cleaner, it's quieter, it's more efficient, and I hope to show you perhaps even a little bit cheaper. So it's very important. And then, of course, all of this is good for the HVAC industry because it means growth, it means jobs, it means lots to do and this change. But having highly skilled, highly trained, and experienced people is absolutely essential. And any mechanical contractor firm going forward has really got to concentrate on this and understand what their capabilities as a firm are. At Mitsubishi Electric, we offer training. We train on our own equipment. It's in supplement to any industry training that you might have. But it's easy, it's free, and you will learn a tremendous amount, I promise you. So we have different courses for different segments of the industry. And we do offer a certification. So any contractor who sends a minimum of 2 people, and the certification goes with each individual. So if that individual leaves a firm, they take that certification with them. It's good for 2 years, and then you can renew it. And it goes on in perpetuity. But it's extremely important because as a manufacturer, we care about the quality of our equipment, and we work very, very hard with quality control and precision to make sure that the equipment is tested, pre-tested, By the time we ship it to site, it's just something that we know is going to be easy to install and it needs to work. But if we get an installer who doesn't quite understand, or it's the first time he's installed something like this, there's some trial and error going on. And in order to eliminate that, in order to extend our quality control right through to the finished commissioning, to the operations of our equipment, we do train people. So we train installers. They're typically 1 day or half day courses. We handle them at our facilities or also at other distributor facilities across the country. And once you have these courses, once you've taken them, then we will issue you the certification. And it means a lot to the warranty that we will offer as a manufacturer. So the standard warranty is 1 year parts and 7 years on the compressor. With a minimal amount of training, that goes up to 5 years on parts. And that minimal training is 1 day. It's a free course, 1 day. So no reason not to take it. And then we go to the next level, which is where my developers are literally demanding. When they put out RFPs, they specify, must be diamond certified. And even bidding on a lot of these jobs, they're looking for that training. So CMO2 is I believe, a half-day course. So you can invest a day and a half. I think we even provide you lunch. And then you can offer your clients the 10-year parts and 10-year compressor warranty backed by Mitsubishi Electric. So that's pretty important. And as I said, developers and owners of buildings are definitely specifying this as a requirement. This is what they want to see. So a city multi-contractor, there's many benefits. I'm not going to read down through them here, but the certification is given when you successfully complete these courses. I think one of the half days, I think it's CMO3, is on commissioning. So each one is dedicated to a slightly different topic or phase of the installation. But once you have this, then we can even recommend you. As I said, I work with developers, and I get the developers and the owners who will then specify to their engineers, please design Mitsubishi Electric. Here's the equipment we've chosen. This is the system we want to use in our building. And then the engineers will design it that way. And when the RFPs go out, as I say, the developers will insist because they want the warranties. So in that case, I get asked all the time by developers, do you have contractors in my area who will bid on my RFP, or who will, even under a limited request for quotation, who can do my job? And we recommend all the time. Developers they want tried and true, so they will look at us and say, who have you got in my region that you'd recommend for my job? Can I get 2 or 3 quotes? So we do. And we have contractors that we work with consistently, but we need more. We're just way too short. We have the best in class instructors. They're certified engineers. They've been working on this equipment. They're factory trained, which means they have been to Japan, they have been to Thailand, in some cases Italy. We have some equipment in Mexico, but they are factory trained as well as full engineers. And they can answer any of your questions. You'll get a wonderful day worth of training. This is just a shot of one corner of our training facility in our head office in Markham. But the little map down here, we do have offices right across the country. Each of our distributors has perhaps a smaller version of this. And our trainers do go from Markham, from our head office, Mitsubishi Electric, to our independent dealers, independent distributors, and do the training at their facilities on a schedule every year. This is 2 of our websites. So if you haven't had a chance to check this out, there's tons of information here, www.mitsubishielectric.ca. That'll come up immediately. In the training, or if you're working with any of our distributors, they will give you access to our technical site, which is here. And in this site, there is literally submittals, there's equipment, there's installation guides, there's data books. there's every technical piece of information you could want on any of our individual pieces of equipment. And there's hundreds of different models, different styles and sizes, but it's all in this technical site. So at any time, you have access to all of that information. Bidding RFPs. This is something I know you all do, and I'm sure you spend a lot of time, but sometimes it may get in the way of other work that you've got. I know you're busy. I know you're scheduled, but spending some time to develop a standard RFP response, something very professional. I see them, and believe me, I see every style and color you can possibly think of. And I would say most of them are inadequate. So that's why I stuck this slide in here. Please be professional, make sure that you get it in on time, but tell us your capabilities. Please let us know who you have on staff, who's licensed. And if you can put in there that you have certified diamond certification, so therefore you can extend warranties, those are huge. And those will definitely get you work and get you jobs. It makes your bidding process very worthwhile. And that is valued. It's not always low cost anymore. Developers are very well educated. They're getting educated every day. And they'll say to their engineers, we want to make sure that we get this and this and this. Low cost, it doesn't cut it anymore in this industry. It has to be, well, I say here, high value. It has to be experience. We also, as I said, you're talking to the customers, you're there. Depending on the project, you may be talking directly to some of them, but certainly you're there with the other teams, the other disciplines on that site. And if you know a little bit about the case for energy efficiency, why are we doing this? Why is it good? Why do we value it? And why have we all decided that this is the direction we want to go? If you have that kind of background understanding, it will truly help you in your job to know what you're contributing to the project and how everybody else can certainly meld in with what you're doing with your process. There's a lot of regulations and some incentives. I think we might see more in the future, but I thought I'd go through a few of them here. Not that you're going to sit down with your customer necessarily, but just understand that some of these do exist and not all clients understand that. So, I mean, we're all aware of the National Building Code. It tends to lag the provincial and the local building codes, some of the municipal building codes. But I think there's a real initiative right now to rewrite that National Building Code. And it's being developed as we speak. The National Research Council of Canada will be publishing. And I think you're going to see that come out. I think it's 2025 that the next one will come out. The provincial building codes, however, they used to change every 5 years. Now I'm shocked if I don't see changes at least once a year. And they certainly surpass the national building codes, and they are mandatory. The training and education laws change constantly in the provinces with regulations, so that certain certifications are required to work on certain systems. So another organization that we belong to, Mitsubishi Electric, is a national sponsor of the Canadian Green Building Council. And for years, this council has done a terrific job of leading, of being ahead of the curve in terms of setting what could be, doing a lot of testing in buildings. They used to do a lot of pilot projects. We're sort of beyond that at this point. And they've migrated from the LEED system for energy efficiency into zero carbon. So now it's the carbon that really takes precedent. But the Canadian Green Building Council, they offer all kinds of courses, most of them online. They offer their annual Building Lasting Change conference. This year it's in Toronto in June. So they're probably the dominant organization driving this electrification. And you'll find all kinds of research material and so on their site. Sustainable Buildings Canada is a smaller organization, but nonetheless, they do have some really valuable program. The main one being sponsored by Enbridge, and it's called Savings by Design. So buildings will enter their proposal and they will go to a charrette and they'll be given information about how to improve the building and make it meet additional standards. The Natural Resources Canada is another place you can go to. I think you're all aware of Energy Star appliances. Most of our equipment is all Energy Star certified. And there are certain grants that homeowners and so on can get online. This is a hot topic. Everybody knows about the carbon tax, and it's not always in a positive light. But nonetheless, even if we do have a general election, even if somebody politically, there is risk, certainly, if this program does go away at some point in the next few years, it's already had a major impact on our behavior and on our thinking. It's taught us to think a little differently about our true cost of using fossil fuels. And what does that really mean to society in terms of our environment, in terms of the changing climate, the fires, the floods, the hurricanes and storms that have gotten so intense. But so the awareness is there, and it's accelerated the change to EVs for sure. That has just all of a sudden landed as a huge topic over the last 2 years. And, you know, in other sectors as well, in the building sector as well. So we've learned, it's taught us some of that, what's that cost equation of carbon and the destruction it can handle in society. In terms of regulations and incentives, the Save on Energy program has had, it's by the ISO in Ontario. There are others in other provinces. It has not meant a huge amount of money. It's been more important, I think, for residential folks refurbishing their houses. In terms of retrofit, the program was just revamped and relaunched about 6 months ago. So it now does apply to commercial buildings much better than it did before. But almost every building project today takes advantage of some incentive from the Save on Energy program. Very important is the Toronto Green Standard. Toronto has definitely led the way. They've been bold in this green standard. It's now accelerated from 2010. We're now up to what's been certified version 4. And the criteria of meeting this Toronto Green Standard has gotten very significant. I deal with this day in and day out. People come to me and they say, okay, we've done our energy model. We can meet this level. We need to meet this level. What can we do? And we go to work looking at heat pumps and how can we apply them and how can we install them and what's going to save them the most carbon and the most energy. This TGS, as it's called in the industry, the Toronto Green Standard, it applies to every single project. So there isn't one that doesn't, it's mandatory to a certain level. And then the voluntary levels allow the developer to get a rebate on their development charges. And trust me, they all go after it. They do want those rebates. And in some cases, those rebates actually finance some of the upgrades that are required to meet the standard. Another one that's really come on the scene, particularly in the last year, is this CMHC rental construction financing. Anybody, you know, I mean, I've been in this industry a long time. Up until about 3 years ago, rental facilities were just not built. It was, you know, you had your older, but between rent controls, there was just no market, no incentive for anybody to build a rental building. Today, it's all about rental buildings. It's just amazing the number of multi-res buildings that are going up across Toronto particularly, but in other cities as well. And they all want to get this CMHC financing. So they have to meet certain criteria of carbon reduction. And I often will get building drawings, mechanical drawings submitted to me, sometimes by engineers, sometimes by owners. They'll say, look, we need this financing. You have to help us. What can we do to get this? And we begin to convert it to water or air source heat pumps. And we do meet by converting it to an electric building. We do meet not only their tier 1 to get their financing, but usually we can meet their tier 3. And I have one project right now where their ambition was just to meet tier one, just to get their financing. Then the energy modeler said, well, if you just add this little bit, you can actually get tier two, and you'll get this amount of financing with a reduced rate. So they did the math, they crunched the numbers, and they said, yeah, that pays, that's good. And then the energy modeler came back and said, well, if we just add this little piece, then we can get you to tier three. So again, they went back, crunched the numbers, and came back. So the incentive, the reduced financing fee, actually paid for the improvements, the heat pump improvements that they added to the building. HRAI, you're all familiar with this organization, and it's another great source for training, for courses in all the disciplines. And you'll just find it a wealth of resources that I know you can tap into. So I wanted to show you a couple of sectors where there's huge opportunity. You know your market, you know what your specialty is, but mid-tier commercial building sector is massive. And I was surprised by this fact. 53% of energy-related projects are identified by the contractors, by people giving them proposals. Here's what we think we can do for your building, and this is why we think it's a good idea. So having that capability within your organization will definitely bring you business, no question. A lot of these buildings are not well understood by the owners in terms of their mechanical systems or their performance. And if you can help them understand and know what to do, there's huge opportunity in this sector. We have to tackle these buildings. A lot of them are full of glazing, a lot of them are leaky, and a lot of them do not perform well. I've already mentioned the purpose-built rental housing sector, and it is very, very important and only growing and going to grow more. Even Toronto City has said they're going to get in the business as a developer. We'll see how that works out. But you can see the growth in population just in Toronto here up to 2041 projected to be almost 10 million. Where are those people going to live? They are not well serviced today, that's for sure. And another piece, you know, it looks like we're going to need 124,000 units in the next 10 years projected right now. And I mean, a lot of these projects take 5 years at least to be approved. So we do know what these numbers are. And right now it's 47,000. So not even half of what we need. And that's built. So we need to start now to get these done. So these are both huge sectors, I think, of great opportunity that you could take advantage of and go after. So I thought maybe we'd talk for a few minutes about electric heat pump technology. And I know you're all pretty aware of it. When I started in this industry, nobody knew what I was talking about. But today, I think it's pretty common knowledge. I just wanted to review with a couple of slides why heat pumps are the chosen one, if you will. So variable refrigerant flow, VRF, has become very common. It wasn't 5 years ago. We were still trying to explain what that meant, and it was a mouthful. But refrigerant acts differently than water or gas or air, and I'll show you that in a minute. And VRF technology has emerged as certainly the leading edge in terms of emission reduction. Variable compressor speed inverters, you pretty much all know what that is. And hyperheat inverter technology, this is where some heat is re-injected back into the heat pump itself, allowing us to have these pieces of equipment work. This says minus 30 degrees Celsius. We can get heat out of air at minus 30. In fact, our newest models are at minus 32 degrees Celsius. So at the coldest temperatures that you're going to experience here in southern Canada, we can actually get it out of an air source heat pump, and we can heat a building very, very adequately with that equipment. It used to be more like if you hit freezing, and there's still that hangover impression, if you will. People still remember those days. So sometimes when we talk about air source heat pumps, I still get lots of people that say, yeah, but they don't work in the winter. Yeah, they do. They do. We've overcome that big time. So in a system, this is kind of how the systems get put together. It's kind of a selection of some of the equipment. So we have the condensers, which can be either air source or water source. In this case, it's water source. We have what we call a BC controller, which is a diffuser. It's a box that takes 2 pipes from the condensers, and we can attach up to 16 fan coils or diffusers directly to that BC controller, or we can pony boxes on that BC controller, so we can do almost an infinite number. And this allows us to do heat recovery. Each of these fan coils can be in a different temperature on a different side of the building. Maybe the sun's shining on one side and it's cold on the other side where it's shaded. The refrigerant circulates back into this BC controller, and whatever heat is returning to the BC controller will be sent back out again to another fan coil that's calling for heat before it goes back and turns on the condenser again. So this heat recovery, this BC controller, is very, very efficient, and it just augments the already efficient system using the heat pumps. This is an AE200. It's a central controller that you would put on an entire building. You can even connect multiple buildings into the controller. So it's an interface where you can see the operation of each individual fan coil. Each one has its own local controller, but this will override, it will diagnose, it will monitor, it will measure, it will, in some cases, condominiums, they even use it for billing each individual suite. So because it's all digital, electronic, connected, the whole system talks to itself. You don't need a third-party building automation system, and you can even interface other security systems and lighting and so on into this, and it's already built into all of this equipment. Some of the other systems that we have very high temperature domestic hot water, so we can actually take an air source heat pump, even at the colder temperatures, and we can heat full hot domestic hot water with air source heat pumps. We have rooftop DOAS, dedicated outside air source, so fresh air being brought into the buildings. We can certainly do that with rooftop units. And then we have a hydronic unit, which is air source, but it produces tempered water that can now connect into existing hydronic buildings. So we have a lot of buildings today that are a 2-pipe or a 4-pipe water system, and they have chillers, many of them aging and performing badly, chillers and boilers, but it's the chillers that tend to go, so we can replace them with this unit, which is made in Italy. So there's lots of features and benefits. I'm not going to go through an entire list here, but some of the advantages, these are, I mean, think of it as a big Lego set. It's plug and play. There's all the different pieces. You can configure it to fit any building, any size. And it really is small and compact. It can fit into existing buildings. It can fit into new construction. In new construction, we even give them back space. I have one retrofit building in Toronto. It's a huge, massive cement building that was built many, many years ago. And in that case, it had a whole entire mechanical floor on the 3rd floor and another one on the 19th floor. And we're actually giving those 2 entire floors back to the owner to be converted into rental space, because the air source heat pumps will sit on the roof. And we can put all the diffusers and so on down into the system without requiring that floor space. So for that developer, for that owner, they're actually gaining enough rental space that the rentals from those 2 extra floors are going to pay for this retrofit in less than 5 years. So it's huge benefits that go just beyond lower carbon and better controls, better efficiency. Sometimes it even goes into the architecture of the building. How can we improve that and give more space? Just again, back to the fundamentals, 1 or 2 slides here. People sometimes forget, so I'll just review it very quickly. If you try to move a volume of air, BTUs, if you try to move them using air, it uses a huge duct. You have to pump a large volume of air in order to heat that space. If you use water and then you have a diffuser, such as a fan coil, something like that, the pipes are much smaller, but you do have pumping power. You have to pump that water. And in the case of a 20-story building, you're pumping that water up and down that building in many, many different risers throughout usually the perimeter of the building, which connects. If you use refrigerant, if you compress it, it'll evaporate at minus 40 degrees C to a gas. So it takes virtually no power at all to convert it. It's an expansion and compression, and it will travel and it will carry a huge number of BTUs through very tiny pipes, 3/8 and 5/8 inch. So the impact on the structure of the building is massive. It just reduces everything down to tiny compared to some of the other systems that we're replacing. So a heat pump contains all of the functions that are inside this blue box: the expansion, the compression. This is an air source unit. It could be a water source unit. It just depends what you're doing. And of course, they're reversible. We all know this, from heating to cooling. So the same system, the same piece of equipment, supplies the air temperature from the lowest to the highest, and it can keep that building comfortable all year round. In traditional systems, we've got natural gas for heating and electricity for cooling. And the electricity part is not efficient. It's usually running 1-to-1. In the natural gas, it's running, much less efficient depending on the age of the boiler, and also the fan coil equipment and so on that's inside. So in this case, you've got one system and it operates to supply that entire building. So the equipment cost needs to be amortized over being able to do the full year, not just seasonal. If you look at electrification of a building, how much energy does it take to deliver 1 million BTUs? So let's think about that. The answer I get to that in many cases is, yeah, but electricity costs more than natural gas. So let's think about that. I did a little math. If you take a natural gas boiler at 87% efficiency, you do the math, it takes 31 meters cubed. So you price that out, and I did at today's prices. I just did this in October, so it's fairly current. And yeah, so $1,567 was the cost to deliver 1 million BTUs using natural gas. Using an air source heat pump with a COP of 3.82, and that's an average. It goes much higher than that in the summer and somewhat lower than that in the winter for sure. But this is the average. AHRI publishes these statistics after doing testing on the equipment. So it's what I went with. We come up with 77 kilowatt hours to deliver 1 million BTUs. And when I costed that out using the OEB website, I came up with $11.86. So first of all, the air source heat pump is not only just as efficient, well, much more efficient, but it can deliver the same amount, but even the cost is less. We look at this in terms of carbon reduction. So again, using some of the figures, I just happened to pick up, the emission factors for Canada for 2017. I think they're probably a little bit better by now because we have brought on more renewable energy into our grid. But nonetheless, I used those numbers and look at the difference in the kilograms of CO2 equivalents. It's ridiculous. It's such a difference. 81% reduction of the carbon emissions, and it costs less. So here's some people that get it. Here's a few projects where, the owner has certainly got it. Siftons in London are developing an entire zero carbon community. This was the first building they built there. I think it was 2016, but they are now on building 15 or 16. It's a huge community that involves multi-residential as well as office. This was an office building. They built it as their headquarters so that they could build out the entire community. but you can see what it means. Here's all the air source heat pumps on the roof. A lot of this over here, these are all solar panels. So between a combination of solar and air source heat pump, there's a lot of technology in this building, but it's been operating for many years and it continues to meet its net zero standards. I was involved in the design of this one, Evolve 1. This one is in Waterloo, just north of the university. It's an office building, and it was the first one that met the Canadian Green Building Council Zero Carbon Building Design certification. But I wanted to show you this little chart on the bottom here because I was involved with an integrated design team. And as the engineers worked on all the different areas that they thought that they should be able to economize on energy and on carbon. So they started out, with the envelope, with the building, what are the characteristics, the orientation to the sun and all of that. Then they looked at the lighting and plug loads, the electricals, and they looked at passive systems. So they had mechanical ventilation that was a passive system of rising and falling air. And then we got into the high efficiency mechanical. This was the VRF system, the air source heat pumps. And all of a sudden they started to meet their numbers. So these all contributed, no question about it. But the biggest contributor, 52% of the energy savings they needed came from the VRF, heat recovery air source system. And then of course they looked at other things. So they had some heat recovery on water systems and on sewage. And then they also looked at the operating schedules, how they set the temperatures and the lighting. The end of this building is actually vanes that turn and migrate with the sun to shade the windows, and the back of this entire building is actually thermal solar. So as well as the PV solar that was on the roof. So very innovative, but easily done. And this building's been in operation since 2018. And again, annually meeting its zero carbon certification. Aquabella, here's a huge building. So it doesn't have to be just smaller buildings or office buildings. This is a multi-residential building in Toronto, right on the waterfront. And this was just one that I chose. There are several. Tridel has 3 of them stretched along the waterfront. But again, just to show you an example, this was a water source. Now this is what we call a mechanical water source, because instead of using geothermal, like Evolve 1 did, this one uses boilers and chillers, or a cooling tower, not a chiller, boilers and cooling tower to work with the heat pumps. And so the heat pumps do the majority of the work, but they still need a small capacity to feed the water source. Systems for homes are also very prominent these days. I mean, we've all got an air conditioner. Why don't we put in a heat pump so that we can do our heating as well as our air conditioning? And communities, whole communities. This is called a Zuba Central system right here. It replaces a furnace. So the condenser sits outside, the refrigerant travels into the basement, into this box that would replace the furnace. And then this is a forced air system through the building. This tends to work very well for townhouses where you have individual ownership and people want to own their own system. They don't want to be on a shared heating and cooling system. To be honest, don't ask me why, because we've designed systems that are very efficient for clusters, these blocks of townhouses. But the norm is still, the convention is still to own your own heating and cooling system. So this Zuba Central works very well. We also have ventilation that can be on air source heat pumps. So rooftop units, this has become more and more prevalent in my conversations with the market, especially over the last, I'd say, 1.5 to 2 years. We have huge retail organizations who have stores, some of them 1,500 stores across the country. And all of a sudden they want to get rid of their rooftop units. They're aging, they're sort of a dog's breath, because in many cases they've got 2 or 3 on even a small facility. And we're looking at how can we replace those rooftop units to get them much more efficient. One way is this air source heat pump. This is a dedicated outside air source system, and it can replace a rooftop unit. So depending on the size of the facility, this ranges from 5 to 30 tons in capacity, or sometimes we need 2 or 3 of these units, depending on the size of the building. But this is one way. So you've got cooling options. This is almost a custom system. When we start working with a client, we tend to ask a lot of questions with this one because it is customized, and there's lots of different options that can help them to make sure that it's exactly what they want to fit their facilities. An example is the Deloitte office. We did a retrofit on this old building. It's about 1800 that building was built, but it now is sporting a brand new air source heat pump fresh air system. The Guelph Police Department, we do a lot of police departments. We just did the OPP here in Brant County where I live, and many, I know we've done Peel, we've done, a lot of the police services have done their buildings. This was an apartment building. This was a developer I worked with. He built a purpose-built rental building, and it was all outfitted first with a water source first, and it is geothermal. So the boreholes were drilled. The water source geothermal system now feeds the water source condensers that are on each floor. This was a little closet on one floor. And then the BC controller is mounted in the hallway, and the fan coils go into each suite. On the roof, to provide their fresh air, is a premises unit. So this building, extremely efficient, very clean, quiet, gorgeous building. ERVs, this is another technology that's been around for a long time, but it's really coming into its own right now. These are boxes that are mounted in a ceiling, and they can temper air both incoming from outdoor as well as leaving the building, stale air leaving the building. So there's a filter in the core here. The air passes through that, and it filters not only temperature, not only heat, but it also filters humidity, which makes a huge difference, especially in the summer for cooling. If you can keep out the humidity and the heat as that fresh air enters into the building, you're ahead of the game already before you start moving that air to provide fresh air to, throughout the entire building. When the air is leaving the building, especially in the winter, we don't want to send all that heat that we just produced inside the building out, but we do want to send out all the stale air. So again, it filters in both directions. So an ERV can be connected to the heating and cooling system so that it becomes all one when you're experiencing it inside the building, the occupants. So the air source condenser sitting on the roof, we have a whole building controller here, the BC controller with 2 pipes, refrigerant pipes in and out to each of the fan coils throughout the building, various spaces. The ERV is mounted separately, but it is ducted into these fan coils so that the air heating and cooling the space is also tempered by the ERV. And this is extremely efficient. You've got the compounding efficiency of the condenser, of the BC controller, which is providing heat recovery, and also from the ERV, which is tempering that air. We did this in our own building. So this is our head office in Markham, and we did a complete retrofit of this building in 2022. We did it in 2 phases. So this was our original rooftop unit right here. This was our monster. It was a 90-ton rooftop unit. We rarely used it, but it was there and it was costing money. It was requiring a whole lot of maintenance. This was removed completely. So the equipment we installed was air source condensers on the roof, and we have them elevated. We always do this on stands because it's above the snow line to make sure the snow doesn't clog everything up. And we were able to reduce to 60 tons. 90 was way oversized for the building. It just wasn't required at all when we did the engineering. We put in 9 BC controllers, and we have 44 diffusers, both cassette diffusers as well as ducted. So we attached all of this system and we run the air through 8 Losny ERVs. So this has produced, so here's the rooftop unit right here that's now dismantled and gone. And we installed these heat pumps on the roof right here in various locations. So this was how we zoned the office space. We also have a big warehouse space out behind here. But, so each of the heat pumps, each individual heat pump is servicing one of these zones. We've preserved 2 of them because we have a new technology called hybrid VRF, which instead of running refrigerant from the BC controller into each space, we use water. So it reduces the amount of refrigerant and reduces some of the problems, particularly for small areas like nursing homes. We ran into issues of standards where you're not allowed to have a concentration of refrigerant in an occupied area. And sometimes we get suites that are tiny. They're little 200 square foot bedrooms. And to put a complete fan coil and, a dedicated fan coil in that space, usually the refrigerant was a bit too large. So now we have the hybrid system. So now it's just water that's going into those fan coils. So our own building has become a living laboratory. We have different condensers serving different areas. They are all monitored, metered individually. We are assessing them technically. In some cases over here, we had a lot of little outside offices. This is where some of the executives sit. So we needed those to be very comfortable. So we joined 2 or 3 of these small ones on a ducted diffuser system and 1 fan coil. In other cases, each room has its own dedicated thermostat and fan coil. So this is what it looks like. The cassettes were very convenient for the open areas, for hallways, for our boardroom. This is just a diffuser over here because this is a small office, so it's connected to a different ceiling mounted fan coil. Just to show you, like scheduling, we started out, this was the graph, hour by hour, day by day, that we were getting after the installation of the system, but before we had it all synchronized and scheduled. And from May of 23 to July, it made a massive difference, a huge difference. So it's very important that these things are not only installed correctly, but they're commissioned, set up, scheduled, and operated correctly. It's early days. We don't have a whole lot of data yet, but here's our electrical bills. We're putting them out here for everybody to see. As I said, we did the retrofit in 2 phases because we needed to continuously use and occupy all the space. So phase 1 was the light yellow, phase 2 was the dark yellow. So it's only been these 4 months where the system was operating in its entirety. And already you can see what the savings are. So I compared these 4 particularly over here to 2021 because 2022 was sort of in construction. And if you look at that, we're getting well over 60% savings in energy. And these are our utility bills. We'll continue to monitor this as time goes on. So we did, I talked a bit earlier about this Climaveneta NXN reversing air source heat pump. It replaces a chiller. So it can offer both heating and cooling. It is a hydronic system, so it connects to water. And there are so many buildings that are fitted with 2 and 4 pipe water systems, hydronic systems with fan coils, mostly fan coils, sometimes a hydronic radiator. But we needed something that would fit those buildings without going in and tearing out the system entirely throughout those buildings. And this NXN is filling that niche very, very well. So it operates, these are some of the operating ranges, the temperatures. You can see lots of different sizes. Again, it has to be custom fit to the building to make sure we're sizing it correctly. There's de-superheater features where we can tie into domestic hot water. We can tie into laundry and various other functions within the building. So it's very versatile, or it can just be simple and simply tie into the heating and cooling system. So this was a project, again, that I worked on, and we have 2 condominium buildings here. They were sister towers in the French Quarter in Toronto, down on Richmond Street, and they needed replacement chillers. And so we've worked on this over the past 2 years. There are the units going in. They did require a crane lift. It was kind of dramatic, but we have 2 units, one on top of each of the buildings. So for contractors, a number of different points here. First of all, why Mitsubishi? We have the only 2-pipe system. All the other manufacturers, it's 3 pipes of refrigerant that run in and out of each suite and back to their diffuser boxes. In fact, their BC controllers, in most cases, they might require 3 or 4 boxes where we have 1. So our system is very modular, very efficient. It's been designed for installation to make sure it's compact and easy. We do support the trade. We offer comprehensive training, and we support with all kinds of technical advice. We will have people attend commissioning on site, and you'll find it very easy to work with our team. The units are easy to install. They're modular, as I said. They can be hung and they fit. For example, a condenser will fit in a people elevator. It's been designed that way so that you don't necessarily need a construction elevator. If you've got access to a roof, an elevator shaft, we can take it up. And there's minimum troubleshooting and maintenance. We have a very low rate of any kind of warranty. We do monitor those. We have people dedicated to serving if there's any warranty issue whatsoever. But our rate is running very, very low. And part of this goes to the training of the contractors. We rely on them, and we know that they can install these units effectively and correctly. So thank you very much. I don't know if we have any time for some questions, Jessica, or where are we on time here?
I would say if there are any questions, I would just encourage participants to use the Q&A or the chat function below. Suzanne, I might just ask 1 question or 2 if you have some time. First of all, thank you very much for the presentation. That was very informative. And I think a lot of us took a lot away from that. One of the questions that often comes up when we're having these conversations about electrification is how would you perceive the grid's ability to allow for this transition? That seems to be a constant theme in those conversations. So I'd like to get some of your insight on that.
Yeah, exactly. I've tried to read into this because obviously I'm not part of the ISO, but my understanding is that the grid is keeping up very well. In fact, there's a statement on one of my slides at the beginning where I think it was like about slide 3. I'm not sure if I can flip all the way back there right now or not. But the ISO has said that not only can they meet it, they'll exceed it. I can't remember what the statement was from memory, so I'd have to look back at the slide. But basically they've said that we're good to go. Now, that doesn't mean we don't have to keep building the system. We do. But my understanding is that, yeah, they know what's coming. We're adding renewables all the time. I don't think it's a constraint to electrification of buildings, for sure. I don't see it. I haven't had any indication of that.
The other thing I wanted to just ask for your perspective on, and as I'm sure you can appreciate, and as you all know, our industry is facing some pretty significant labor shortages across the country. So I think there's continues to be a question of where would the best investment be when it comes to training, recruitment, retention, I'd like to get your perspective on that in terms of what do you see as being the most important when it comes to this transition to the electrification of the built environment from an investment perspective for training and recruitment, and where are the needs?
Okay, well, you're going to think that my answer is perhaps a little bit biased, but get the manufacturer training. All the manufacturers offer it, and they offer it free, and it really isn't extensive. It's not a huge investment of time. But get that training. As I said at the beginning, I work with developers, and I can't tell you how many times we work for 3 years, sometimes up to 5 years, until an RFP is actually issued. The design is done. We've done all the analytics, and then we put it out looking for 3 or 4 or 5 bids. And sometimes we're lucky if we get one. Now, part of that is a labor shortage, but part of that is lack of skills, lack of training. They may be great mechanical contractors in the traditional systems, but they don't have the experience or the certifications for the electrification.
Right.
And it's essential. We tend to go back to the same contractors over and over and over again. And they are, exacerbated because they have so much business, they don't know where to turn. But we need more contractor companies to focus on getting this electrification embedded into their labor force. It's, a lot of them are still stuck on natural gas and on other systems, but they're not up to speed. And, I don't know. I mean, I don't see RFPs for a natural gas system, so I don't know what the response is to those because we don't do them anymore. And in Toronto, you won't find another natural gas new construction multi-res building. It won't be built. It won't pass the certifications and get permitted. So this change is here. It's here now, but we really, even if all the contractors out there could just go ahead and take some of this training so that they are certified, and then we get to know you, we know who you are, you're on our list. And every time an RFP comes down, and they come down weekly, we can suggest, we can say, hey, have you dealt with ABC? They're great guys. They know what they're doing. They've done 3 other projects for us.
Great. I'm not seeing any questions within the chat or the Q&A function on Zoom. So first, I just want to say on behalf of the Mechanical Contractors Association of Canada, thank you very much, Suzanne, for your time, for your expertise on the topic. It was a very informative webinar.
Thank you. Thanks for your time. Thank you very much.
Thank you all for attending, and we'll look forward to seeing you again soon. Thanks, Suzanne.
Bye.
Suzanne, it was a great webinar. It's Tanya.
Okay, good. I hope it worked out okay. Yeah.
Yeah, I might reach out to you for in the future for doing something for our student chapters. It's our university students that are in mechanical engineering.
Yeah, no, it's just, when you're in front of your own screen and not an audience, at a conference or something, you feel like you're talking to yourself, and you're kind of wondering, did I explain that well enough? Do people know what I'm talking about, or should I explain it more? Or, it's kind of, you can't, there's no faces to read,
Yeah. No, I thought it was great.
Okay.
And we're always looking to educate our university students too, so I might pull you in at some point.
Okay, well, thanks, Tanya. I appreciate that.
Right.
Okay.
Take care. Bye-bye.
Thanks, Suzanne.
Thank you, Jessica, for all your help. Thank you. Bye-bye.
No problem. I'm glad we were able to do the webinar in the end.
Yeah, got it done. Thank you.
Perfect. Awesome.